Hey, it's Steve. I'm back at the 3.5 by 5.5 foot N-scale layout project, and a lot has been done since the last video. While it may not really look like it, a lot has actually been accomplished. The track has been installed, all the wiring is done for the track, for the turnouts, the controls are in place, the DCC system is installed as well, and everything is pretty much ready to go to progress on to building structures, doing scenery, and that kind of thing. I've also put on a new set of legs and now have a set of metal legs for the layout, which are a lot more sturdy. They can also be taken off and put back on very, very quickly, which is very important since this layout does have to be transported. I've also gone ahead and stained and polyurethane the wood frame of the layout, and so overall quite a few things have been accomplished since the last video. So anyway, let's take a look at how I got to this point. Okay, so before installing the track and the wiring, I went around the layout and sanded the foam smooth so there were no small bumps that would prevent the track from laying flat. Once that was done and cleaned up, I put the track back on the layout and marked out where I wanted the power leads to go. This layout is being wired for DCC operation, and I'm using a Digitrax Zephyr DCC system to power and control things. This base station is great for smaller layouts and has a built-in throttle, plus allows other throttles to be connected. I have also connected a Digitrax panel that I installed into the front of the layout fascia to the base station, and that allows you to plug in some additional handheld throttles. Since the base station is small and lightweight, I have it mounted to the layout with Velcro. I have 2 strips of Velcro attached to the front of the wood panel that I attached to the layout frame using a piano hinge, and a couple of wood blocks on the back side of that panel kind of keep it sticking out at a nice angle and prevent it from hanging flat. The base station and a handheld throttle or two can then be attached to the Velcro strips, but still be removed easily if needed. So when moving the layout, I can take off the Digitrax base station, fold up the panel that holds them, and then the layout will fit into the back of my vehicle for transport. You can see here the locations I decided to add power leads using Kato terminal rail joiners. Those are marked in red, as well as where I put in insulated rail joiners, and those are marked in black. The Kato number 6 turnouts are power routing, and so to help prevent shorts, I put insulated joiners on the frog end of the turnouts and made sure I had power coming in by the point side of each turnout. Even so, if you run a train into the turnout from the frog side and the turnout is not aligned to the track the train is on, a short will occur once the train crosses the insulated joiners. The crossovers, though, are insulated already, and so while they are DCC friendly, you do need to apply power to each leg of the crossover, as power will not flow from one side to the other. You don't have to have the power leads directly attached to the ends of the crossover, of course, but making sure you have power connected to tracks on each side somewhere is important. I tried to make sure there was power connected to each track in between each set of turnouts, as well as in a couple of extra locations for redundancy. Using a long drill bit, this is actually a 5/8" drill bit, I drilled a hole through the thick layers of foam at all the locations where power leads needed to go, as well as where the wires for the turnout motors were going to be located. I then ran the wires down through each hole, and since the holes were fairly large, this wasn't really hard, but if you do have smaller holes, you can always put in a drinking straw into the hole to make it easier to push the wires through, since they do have a tendency to kind of snag on the foam. Once the wires are through, you can then just pull that straw out. The most important thing when connecting the terminal rail joiners or soldering on the wire leads, if you do that, is to keep things consistent. In this case, the terminal joiners have a blue and a white wire. I made sure the blue wire was always on the outside rail, the one closest to the layout edge, and the white wire on the inner rail. This way I could connect all the blue wires together and all the white wires together without creating a short circuit. The Kato single crossover was set up to be power routing. I wasn't sure if this would cause a problem or not, so I moved the screws to the non-power routing locations on the back of the crossover. Once the wires were all in place, I used a pair of wire strippers to cut off some of the excess wire and to strip all the ends of the wires. I then ran a pair of heavier gauge wires down from the Digitrax base station to the underside of the layout to serve as the bus wires. I connected all the blue power lead wires from the track to the blue bus wire and all the white wires to the green wire. I would have used a white wire here, but I just did not have a heavier gauge white wire. Then I had a locomotive running on the layout while I connected each group of wires under the layout to the blue and green bus wires. This way, if I heard the locomotive stop, I knew that I had created a short. Obviously, it probably would have sparked as well on the wires, and I would have seen that, but this way, just by hearing that locomotive running, I knew that things were still wired correctly. Once everything was connected and there weren't any issues, I went back and soldered all the wire connections and then covered them with a couple coatings of liquid electrical tape. When connecting the wires, I try to make sure they are always secure without the solder. I do that by wrapping the two wires around each other, then folding back the wire onto itself so they are securely attached. You want to have a strong physical connection first and not rely on the solder to hold the wires together. When soldering the wires, I like to keep the heat on one side and let the solder flow through from the other. I use a Hakko soldering station that has an adjustable temperature, but generally one that is hotter or higher wattage is going to heat your connection faster. Once things have cooled a bit, I come back with the liquid electrical tape. Often I'll use heat shrink tubing as well, since that is probably more robust overall, but in places where there isn't much risk for wires shorting out or where the tubing is hard to use, I just use the liquid electrical tape. It can be messy, however, so you might want to wear gloves when using it. At this point, I decided to get some bridge piers put in place since that would be hard to do once the track was glued down. I made the piers out of pieces of poplar, just cutting the wood to size and sanding it smooth, and then I glued the piers in place with wood glue and then mixed up some Sculptamold and used that to help blend them into the scenery. While testing the layout with different locomotives and rolling stock, I learned that I needed to shift the two bridges on the front of the layout off to the right an inch or so in order to prevent longer pieces of rolling stock from hitting the ends of the bridge when coming in from the curved trackside. So I added a couple of 1.14 inch pieces of track to the left of the bridge and then adjusted the track pieces to the right so things would still line up correctly. Next, I moved on to drilling holes in the front of the layout for the push-button controls I'm using for the turnout controls. I marked the location I wanted each button and clamped a board to the layout to kind of use as a guide. Then I used a 3/4 inch drill bit to drill each hole since the push buttons have a diameter of just slightly under 3/4 of an inch. I put some wood putty around the inside of each hole as well as around the front edge, so once I sanded that smooth, it'd have a nice opening that was just the right size for each of those push buttons. I soldered wires to the back of each button and then temporarily installed each button in the layout frame. I then hooked up 2 wires to each of the DS64 units I'm using to control the turnouts that will eventually connect to the DCC bus line that powers the track. I attached these with some double-sided tape to the bottom of the layout for now, and later will permanently install them with some screws once I am ready to actually wire all the turnouts. At this point, I moved on to soldering most of the rail joints on the layout. This isn't actually needed, and if your layout will see large temperature swings, soldering every joint will actually cause a problem as the metal rails will expand with hotter temperatures, and that can cause some kinks or buckles in the rail if there's no room for that rail to expand. I have left some of the rail joints unsoldered though, and will cut some expansion gaps in the rails if needed as conditions warm. Since this layout is being built in the garage and it does get into the hundreds here in the summer, I will see as it does get hotter over the next couple of months if the rails do expand and cause any kinks or buckles anywhere. Then I can go through and cut some additional expansion gaps to make sure all the rails are going to be in a good shape when it is in some very hot conditions. At the same time, having a lot of the joints soldered does help with overall electrical conductivity around the layout, limiting the number of dead spots that might spring up over time. Alternatively, you could just use more terminal rail joiners or solder more power leads to the track so you don't have as many rail joints in between each of the power leads. When soldering rail joints, like with wires, I try to apply the heat to one side and the solder to the other to help ensure I'm getting a good solid solder joint. Since the Unitrack roadbed is actually plastic, it may soften while you are doing the soldering. So be sure the rail joints are still aligned after the solder cools. If they are not, you can just come back and apply some additional heat, push the rails back into alignments, and then you should be good to go. Once the soldering is done, go back over each joint and file off any solder from the top or inside of the rail. And this is also a good time to file the joints smooth in general to make sure there are no bumps that might derail a freight car. At this point, I figured I should go and do some painting before gluing down the track. I first painted the bridge piers just a gray color, and then I applied a brown wash of paint under the bridges. Then I painted the same brown wash on the remainder of the layout, kind of moving the track out of the way as I went around. To actually glue down the track to the layout, I simply use my SureBonder hot glue gun and hot glue sticks. The Kato track can be a little tricky to hot glue down since most of the roadbed is hollow, but there are some spots where glue can grab onto. You could simply spread some white glue under the track or even some latex caulk as well, and then that would certainly work just fine, but the hot glue does help to hold things in place quickly. The track isn't firmly attached everywhere, but I'll be gluing ballast down along the sides of the track, and that will permanently anchor the track in place once I do that. I used some metal machinist blocks to weight down the track as I was gluing along, so I wouldn't shift the track out of alignment in the areas that I just applied the glue before the glue dried, and this way I could work a little bit faster and not have to wait for the glue to keep drying as I moved along. Once the track was glued down, I could flip the layout onto its side in order to complete all the wiring in a much easier manner instead of having to do it upside down underneath the layout. I tried to run most of the track wires through some plastic cable raceway to keep them neat and tidy, and doing so not only makes the underside of the layout look nicer, but it also makes it safer to transport the layout since there is less risk that you might kind of snag some of those wires and rip them out. I then moved on to wiring up the turnouts. Again, the turnouts were wired using two Digitrax DS64 units. You don't need to use these, but it does make control of them a lot easier. You could just use the Kato switch levers or your own momentary toggle switches or push buttons, but the DS64 units allow you to control the turnouts by both push buttons, just in fact a single push button, as well as from your DCC throttle. The DS64 units can control 4 turnouts each, and so I needed 2 of those units to control the 6 turnouts that I have on the layout, including the crossovers. Wiring is fairly straightforward, but you do have to make sure you don't connect a wire to the wrong terminal. First, I connected all the wires from the push-button turnout controls to a long terminal strip, and then I added another terminal strip to connect wires from the DCC bus to, and then from there to the DS64 units. This way, if I needed to remove one of those 2 units, I wouldn't have to actually worry about any solder joints, and all I had to do is remove the wires from those terminal strips. Then it was a matter of connecting the 2 wires from each turnout motor to one of the 4 pairs of connection points on each DS64 unit. The connections on the DS64 are labeled for turnouts 1, 2, 3, and 4, and so getting those connections made was easy with the built-in screw terminals. To control the turnouts by momentary push button, you connect 1 wire from each push button to one of the switch control terminals, with the S1 terminal controlling the turnout connected to the first set of terminals, the S2 controlling the turnout to the second set of terminals, and so on. The other wires from each push button are connected all together and then connected to one common terminal on the DS64 unit. So it was just really a matter of making sure I connected the wires from the DS64 to the correct push-button switch wires on the terminal strip. Once all the wires were connected, I again used some pieces of cable raceway to contain all the wires and make everything look a lot neater on the bottom of the layout. The way these units work with push buttons is that every push of the button will flip the direction of the turnout, allowing one button to control both directions of a turnout. So I only needed 6 push buttons to control the 6 turnouts. And these push buttons I found are really nice, and they sit nearly flush to the layout fascia. The buttons themselves do not stick out beyond the housing, and so there's no real risk of snagging those or accidentally pushing them, and they're not going to get damaged very easily during transport. I had originally planned on recessing the buttons so they wouldn't be damaged in transit, but again, because they're so flat, they can basically just sit flush on the layout fascia. While I don't have any lighting installed on the layout at this time, I went ahead and set up a 12-volt power supply, controls, and a couple terminal strips to make it easy to connect lighting later in the layout build process. I have a regular light switch with 3 toggle switches on it that you would just use in your house, typically on the wall, built into the layout fascia, and each of these buttons in turn can be set up to control one set of lights or other accessories. The wires from the power supply and the switches are all connected to a terminal strip, and then I can connect wires from the terminal strip to groups of layout lighting and so on later on. So I might have one switch control structure lighting, one control street lights, and another control lighted signs or other accessories. And so you can see the completed layout wiring here, well, except for the future wiring that will be done for the street lighting and that kind of thing. I have my DS64 units in the middle here, the terminal strip above that joins the wires from the push buttons to those that connect to the DS64 units. the Digitrax panel up on top here for connecting the handheld throttles. That is in turn connected to the Zephyr base station by a single cable. All the wires to the control switches for the layout lighting run through the fascia here on the top right, and then to this terminal strip to which I can connect the future lighting. All the wires to the Digitrax Zephyr base station itself run up through the layout here on the top left. Then I have the power from the base station as well as a 12-volt DC power supply connected to an extension cord mounted to the underside of the layout here on the left, and so only a single power cord is needed to power everything on the layout. So another change I made at this point was to actually install new legs on the corners of the layout. I originally used some wood legs that screwed onto the layout base, as well as a set of bolt-on legs that were a lot sturdier. While those bigger legs looked nice, they were actually pretty hard to put on and take off because they had a lot of bolts to use. And the smaller legs that screwed on, were very easy to put on and take off, but they weren't really very sturdy and not really good for, permanent use. So I looked around and found this set of metal legs at the tablelegs.com website. This kit includes heavy-duty plates that you can screw onto the bottom of your table or layout project, and each are attached with 8 screws, so you get a pretty sturdy connection there. And then the kit also includes plates that allow you to actually fold the legs up so you don't actually have to remove them during transport. And I initially tried those, and that's what I had actually planned to use, but it puts a lot of stress on the bottom of the layout when locking those in place and opening them back up. And so because it is just pine, I was concerned that I would eventually, rip out or even just loosen those plates over time just from the opening and closing action of those legs. These legs are a couple inches in diameter and do have adjustable feet, and this allows you to level the layout as well, which is really nice. So if you have a floor that's not quite even, you can keep things nice and level, and that will also help prevent you from scratching any floor surface that might, possibly get damaged from the feet. The legs thread on very easily. The metal plates have a bolt welded on, and then the legs just thread on and thread off very easily. So it's very easy to transport the layout by taking the legs off and putting it in the back of your vehicle. And at this point, I decided to actually finish the layout frame. I sanded everything down with a series of coarse, medium, and then fine grit sandpapers on my orbital sander to get a nice smooth surface to the wood, and also to sand off any of the glue or paint and so forth that was on the layout frame from doing the initial scenery work. And once that was done and all the dust wiped off, I taped off the controls and then put 2 applications of a cherry stain on the layout frame, wiping off the excess each time. And then after a day or so of drying time, I applied 3 coats of satin polyurethane. The poly coats give the wood a lot of protection, making it more resistant to damage, and also give the wood a much richer look. I do plan to cover the wood while I'm working on the scenery work going forward, but this way, if I do get any paint or glue on the frame at this point in time, it's not going to soak into the wood, and I should be able to clean it off fairly easily. I may have to go back at the end of construction and kind of lightly sand everything down one more time and then put a final coat of polyurethane on to make everything look really good once everything is complete. So once the final coat of polyurethane had dried, I installed the controls back on the layout. I simply glued in the push buttons with some hot glue, and then the other switches for the layout lighting and for the control panel for the throttle units were attached with screws. To hold the Zephyr base station, I used 2 strips of Velcro on the back of the Zephyr unit, and then ran 2 horizontal strips of Velcro on the wood panel it was mounted on. And so to make sure that adhesive Velcro wouldn't actually pull off over time, I attached each strip with 3 additional screws as well, and that would securely anchor the Velcro to the wood so it wouldn't, pull off at some point down the road. And so this way, I'm able to just stick on the base station very easily. It's very secure that way. It's not going to come off. And I can easily attach or, remove the throttle units that might be plugged in as well to that strip of Velcro. And I might add some additional Velcro patches here and there on the layout frame, just so there's a few extra spots to kind of hang your throttle units. So at this point, the layout is looking pretty good, and the trains are running reliably all around the layout. The wiring did take a while to do, but now that part of the work is done, and I'm ready to move on to scenery and structures, which are always a lot more fun to do. Since that part of the work does typically progress a lot faster, we should see progress on this layout here move along a lot faster in the coming months. So anyway, that's a look at where things are at with the 3.5 by 5.5 foot N scale layout project. In the next video, we're going to weather the track, ballast the track, do some of the final sort of base scenery, get all the mountain on this side of the layout completed. We're going to go ahead and get some of the other little base scenery items done and start working on the structures. So if you haven't already subscribed, please do so you don't miss that next video. But anyway, that's all for now, and thanks for watching. Bye.